Hello. Okay, so I'm trying to fix my microphone, but I know the sound quality isn't brilliant on this microphone, but we'll do our best. What I want to go through today is the formula for ionic compounds. So before you do anything else, I'm going to draw a structure I want you to write up. I want you to draw an arrow that looks like this, an arrow that looks like this, and an arrow that looks like this in your books. So pause the video now and make sure you've got that in your books ready to go. What we're going to look at is, in our last lesson, we know that there are ionic compounds that have high melting points and have specific properties like being conductors when they're molten or aqueous. This is my drawing of table salt, sodium chloride. We know that's the name for it. Now we know if we zoom in on it, then it's made up of a lattice of ions, positive and negative repeating, next to each other, and they're held together by electrostatic forces of attraction. We know that this is what gives ionic compounds their high melting and boiling points and their other properties. But also, in addition to that, we want to look at the formula for these compounds. Now, if you were to represent sodium chloride with a formula, it would be NaCl. So one of the things we can't do is, because we know that ionic compounds are giant structures, they're made of billions and billions and billions of ions bonded together, we can't represent all those sodium ions and all those chlorine ions as we wouldn't write sodium followed by 1, 2, 3, 4, 5, 6, 7, 8. We wouldn't write that, for example, as the formula, because we don't know how many ions are actually in a giant substance, and so we need to simplify the formula down, and we do it using this formula here, NaCl. We say the ratio, every sodium ion has got one chloride ion to go with it. Now some substances, let's say if I change the name of this to calcium chloride will have a different formula. It will be CaCl2. Now what this is saying is, for every one calcium ion you have 2 chloride ions. We want to be able to work out what the formula is for any ionic compound under the sun. And so to start with, we're going to have to learn how we can find the formula for different ions using the periodic table. Okay, so times are quite tricky at the minute, so I've only got one periodic table in my entire house at the moment, and it's in a book. So here's a very old periodic table. As you can see, it looks slightly different to some of the ones we've used in the past. The atomic number and the mass number are left and right, so it's a bit tricky to work out. But what this would allow me to do is show you where we get the formulas for different ions from. Now, I would recommend, if you aren't able to print a periodic table, try to draw one up that includes maybe these first 1, 2, 3, 4, 5 periods. The first 5 periods here, I'd maybe draw that up if you have time. But we're going to be focusing on the groups themselves. Now, we know from year 8 and from previous lessons, this is called group 1. Group 1 elements form 1+ ions. Group 2 elements form 2+ ions. Group 3 elements, 3+ ions. Now carbon can go either way. Carbon can be, carbon's in group 4. Group 4 elements can be either 4- or they can be 4+. Nitrogen, or anything in group 5, any element in group 5, so this is group 5, is going to have a 3- charge. Anything in group 6, that's this row here, is going to have a 2- charge. And anything that has anything that's in group 7 is going to have a 1- charge. And so you can see there's a pattern. It goes 1+, 2+, 3+, and then 4 minus or 4 plus, 3 minus, 2 minus, 1 minus. Now these elements here, called the noble gases, they don't form ions. They will never become ionized. So we're not going to focus on those. But this means that we can use a periodic table, and if you don't have one, I'm sure you can find a digital copy that has these numbers on as well. But if you can remember the charges on these different ions, then it will make determining the formula for ionic compounds much easier. Okay, so let's say I wanted to find, I'll just do some worked examples. Let's say I wanted to find the formula for a magnesium ion. Magnesium is in group 2. I know group 2 ions form 2+ charges. So the formula for magnesium ion is going to be Mg2+. Let's try an element. Let's try sulfur. Sulfur's in group 6. It will form a 2- ion. So a sulfide ion will always have the charge 2-. Bromide. Bromide's in group 7. So group 7 elements form 1- charges. So it's Br-. Let's try one more positive one. So boron's in group 3. We know that these group 3 ones form 3+ ions. In fact, we'll do one in this one as well. Now, if we had, say, silicon's in group 4, we could have 2 different ions. We could have Si4- or Si4+. It can go either way, and it depends on what kind of compound the silicon is in. So that's how you can find the formulas of different ions in the periodic table. So what I want you to do now is, pausing the video, I want you to copy down the names of these 4 ions. And what I want you to do is go back to the periodic table that I was looking at before. So rewind the video with the video paused and this in front of you, and use the periodic table that I put up here to find the charges for each ion. Okay, when you've done that, I'm going to write the answers up just here, and you can mark your answers. Okay, so sodium is Na+, fluoride is F-, nitride is N3-, beryllium is Be2+, and calcium is Ca2+ as well. So there we go. We've worked out how we can find the formula for an ion. Now, there are also, we know the definition of an ion is either a charged atom or group of atoms. The ions we just looked at are called monoatomic ions. They are made of one atom. Mono meaning one. However, there are some ions which are poly meaning many or more than one atomic ions. And we need to know the formulas of these off by heart. There's no way of using the periodic table to work them out. I'm going to write them all out. I want you to copy them into your notes and make a flashcard that says, make flashcards where it says what is the name of this ion, and you're going to write the formula on the other side of the flashcard. Use Quizlet if you don't have any paper flashcards at home, but that will help you to revise and learn these polyatomic ions off by heart. So the first polyatomic ion is called a sulfate ion, not sulfide, sulfate. It's got the formula SO4 2-. A nitrate ion is polyatomic. It's made of more than one atom. It's NO3-. There's ammonium, NH4+. there's hydroxide, OH minus, I'm just seeing, I feel like there's yes, and the last one, carbonate. Carbonate ions have got the formula CO3 2 minus. So you need to make sure that you've got flashcards that say what is the formula of a sulfate ion, and on the other side it says SO4 2 minus. I think I've already got a digital set. If you want to message me on Show My Homework, I can send you the link to the digital ones, but you need to know these ions off by heart because it'll make everything else a lot easier. If you look, there's no way to predict what the charge of these ions is going to be. You just have to you just have to know the formula of these ions off by heart. This is essential for you being good at chemistry. If you want to work out, if you want to understand lots of the chemistry you'll go on to do when you start in year 10, you need to know these ions absolutely 100% off by heart. Okay, so now let's talk about working out the formula of ionic compounds. So let's say we've got an ionic compound, sodium chloride. Now sodium chloride is made of a metal and a non-metal ion. We want to find the formula for it. In other words, we want to figure out how we can represent it with symbols. So there's going to be 4 key steps that we're going to use, and I'm going to do a worked example, and then you're going to have a go at one, and then you're going to have a go at another one. Make sure you've got your answers right. So first thing we're going to do, draw a box. That's step 1. Step 2, write the symbols for each of these two elements in the box. So we know that sodium has got the symbol Na, and we know chlorine has got the symbol Cl. Okay, step 3, using the periodic table you need to write the formula for each of the ions for these elements. So what I'm going to do, I'm going to look for sodium. Sodium's in group 1. I know it forms a 1 plus ion, so I know its formula is going to be Na plus. Chlorine's in group 7. It's got a 1 minus charge, so I know its formula is Cl minus. Right, step 4. Now in step 4 I'm going to draw a box underneath this one and draw a line down the middle. What I'm then going to do is I'm going to put the ion with the smallest charge, in this case they both have the same size charge, into the box, with the largest charge, sorry, into the box first. But these two have got the same size, so I'm not going to worry about it. I'm just going to write Na plus underneath where it says sodium here. So there's my sodium ion. Now, a really important rule for working out the formula of ionic compounds. The formula on an ionic compound overall must be 0. In other words, the charges must cancel out. You can't have one of these being charged overall. So if the charge on this is +1 and the charge on this chloride is -1, I'll only need one chloride to cancel out that charge. So this NaCl is the correct formula. Okay, I'm going to do another one this time, but I'm going to do it without writing all the steps out. So I'm going to make a change. This time we're going to do calcium chloride. I'm going to draw a box. The symbol for calcium is Ca. Symbol for chlorine is Cl. I'm going to write the formulas for each ion just here. So Ca, calcium is in group 2, so I know it's going to be a 2 plus ion using my periodic table. Chlorine's in group 7. I know the charge on a chloride ion is -1 because it's in group 7. What I'm then going to do is draw a box underneath, divide it in half. Now Ca2 plus is a larger charge than Cl minus. So I'm going to write this one in the box first, Ca2 plus. Now if the charge on this is 2 plus and the charge on each one of these is 1 minus, to cancel out that 2 plus charge I'm going to need 2 negative chloride ions, like that. So I know the formula for this compound is going to be CaCl2. What I want you to do now, I'm going to make a change. I want you to have a go, pause the video when I've written this up, have a go working out the formula for magnesium chloride. Pause the video now, have a look. Okay, so going through the steps, make sure you've got that. Make sure you've got that. Okay, that's what you should have got. Okay, I'm going to do another one now. This time, I'm going to flip it around a little bit. So I'm going to have sodium oxide. So with sodium oxide, what I need to do is I just write Na and O. Charge, this is in group 1, so its charge is Na+. This is in group 6, so its charge is 2-. But I'm going to be thinking, so now I need to draw my boxes underneath and draw a line down the middle. Now I need to think which one of these has got the largest charge. The answer is going to be O2-, because the number is larger. We're not interested in whether or not it's positive or negative, it's got a larger number. So I'm going to write O2- here. The charge on one of these is Na, is just +1, so I'm going to need 2 sodiums to cancel out that 2 +1 charged sodiums to cancel out that 2- oxygen. So my formula is Na2O. Okay, so what happens if we have two that are the same? Let's try calcium oxide. In fact, pause the video, give calcium oxide a go. Okay, so what you should have got, CaO, Ca2+, O2-. They've both got the same size, so it doesn't matter which one I write in first. The 2+ charge cancels out the 2- charge. Overall, there's no charge on the calcium oxide, so this is the correct formula. I don't need to make any changes whatsoever. Right, now let's do one last one. Aluminium nitride. Okay, so, oh, is that right? Yes, okay. In fact, no, let's not do aluminium nitride, do aluminium chloride. So we'll do aluminium chloride. Should write Al, Cl, so pause the video up to this point if you haven't already. Do it yourself. See, in this case the charge is 3+, so you need 3 negative chlorides to cancel out that aluminium, so it's going to be AlCl3. So those are the worked examples for the easiest kinds, the ones that involve monoatomic ions. What I want you to do now, what we're going to look at now, is polyatomic ions. So this is a bit trickier, because you need to memorize the formulas for the polyatomic ions before you can go any further. So let's say I've got calcium hydroxide. The process is pretty much the same, but you need to be aware of how you need to know the formulas for the polyatomic ions, and you also need to be able to show them in a formula correctly. So firstly I'm going to draw a box. I've got Ca. Now the formula of a hydroxide ion is OH. I'm going to write the ion formula outside here, and you need to just know that. You need to memorize that hydroxide equals OH. So you've got Ca2+, OH-. This is my hydroxide ion. You can't find this on the periodic table. Okay, so I'm then going to write the charge of my largest, I'm going to write the ion with the largest charge into the box first. That's going to be Ca2+. This has only got a charge of 1-. Okay, so here, this is calcium hydroxide. I need 2 negative hydroxide ions to cancel out my 2+ charge on my calcium. And so I know I need 2 of those, but the thing is, how do I show that I've got 2 hydroxide ions in this formula? Well, what I do is when it's a polyatomic ion, I put a bracket around the polyatomic ion and I say I've got 2 of them in there like that. So the last example I'm going to do is ammonium oxide. So for ammonium oxide, is this the best example for me to do? No, I'm going to do ammonium chloride. So under here, the formula for an ammonium ion is NH4, a chloride ion is Cl. Now what I need to do is I'm going to write NH4 plus here, Cl minus here. I found that one from the periodic table. This one I have to just memorize. Underneath this, I'm going to write in the one with the largest charge in first. Now it doesn't matter this case because this has got a charge of +1. This has got a charge of 1 minus. So I'm going to write that in, and you can see they cancel each other out. So ammonium chloride, I don't need to do anything to the formula. The formula would be NH4Cl. Now I said this is going to be the very last one, but I've realised it's probably better if I give you just one more example. Let's do lithium carbonate. Now people get confused when they talk about brackets. In this example I will need a bracket, and that's because I need to show I won't need a bracket, sorry, because unless I need to say I've got more than one of my polyatomic ion, I don't need to use a bracket. So let's start with this. So Li CO3. If you're forgetting how to do these polyatomic ions, you're forgetting their formulas, you need to go back and memorize them. I did them right at the start of this video. Okay, so the charge on a lithium ion, it's in group 1, so it's got Li plus. CO3 minus, 2 minus is the formula for a carbonate ion. I'm going to draw a box. This has got the largest charge. Oops, 2 minus, not 2 plus. And to cancel out that 2 minus charge, I'm going to need 2 of my positive lithiums. And so the formula will be Li2CO3. The only time I need to use brackets is when I need more than one of my polyatomic ion. And so far, there's only one example I've shown you where that's the case. Right, so that, in a nutshell, is how you work out the formula for an ionic compound. I'll put this up on YouTube. In addition, I want you to send me a comment or an email if you don't understand something. You can either comment on Show My Homework, please comment on Show My Homework, or you can email me at my normal email address, which is tschlanker@allsaintscatholiccollege.com. You'll have to write, I'm not going to write allsaintscatholiccollege.com out in full, but that's what my email starts with. Okay, any problems, let me know.